Okay, so welcome back. Now in this, I'll tell you how you can actually return a function using the concept of higher order function. Okay, in previous example, I have given you an idea that how you can take a function as a parameter. Okay, now the second variant is when you're returning a function, and I'll like to tell you the use case of that as well. Okay, so returning a function using HOF concept. Okay, now understand. Suppose I ask you to write a code to return the square of a number. What you will say? You will say def aj square. Okay, it takes a number x and it returns x to the power 2. And suppose I ask you to write a code that returns a cube. So you will say def aj cube x and it will return x to the power 3. Okay, so are you understanding that I have to create so many different functions where the task is just to have a variable that multiplies this? Okay, so what I can do is I can actually create a new function which returns a function on the basis of the requirement. For example, okay, suppose I say def create adder. Okay, create adder x. Okay, understand, slow, step by step. Within this function I will define a new function within this function. Okay, it's kind of a nested function. Okay, so I say def adder y. Okay, and I'll say return x plus y. Now see, you might get confused, sir, you are only taking y here, AJ, you are only taking y here, but you are saying x plus y, because this function is within this function, so x is also available to this. Okay, now this function is returning x plus y. Okay, this function, let me put a enter here, this function is returning x plus y, and this outer function is returning this adder function. Okay, so you are, my dear friends, returning a function. You are returning a function. Okay, and that function is this. Now see the magic. See the magic. Okay, suppose you say add 5. This is a new function that you have to create. Okay, you will simply say create a adder which adds 5 to every number, Okay, so this add 5 is a function which is returned here, which will always take this x as 5, which will fix this x always as 5. Okay, so if you run this, add 5 is storing this variant of this create adder. So now when you say add 5 with only one value y, okay, with only one value y, okay, so let's say 4, so it will give you 4 plus 5 9. Are you understanding the magic? What you have done, you have created a custom function where you have fixed this value of x to be 5 always, and you have created this add 5. So from second time when you use this function add 5, you only have to provide the one parameter which is 4, and it will put this into y, and 5 is already fixed here, so 5 plus 4 9. Okay, so you can say add 5, add 5, and here you can put 10, so you will get output as 15. Now let's say tomorrow I don't want to add 5 to every number. Suppose I want a new custom function which adds 3 to every number. So I can say add underscore 3 equals to, what should I call? Create a new adder. Yes, create adder with x value as 3. So this x will go as 3, and it will create a new function which will have 3 as this x, and this function will be stored here. So my dear friends, in short, what you're doing, you are creating your own functions at runtime by returning a function. Okay, I know how fascinating that sounds, right? So now you can say add 3, okay, and you can call it on 10, so it will give you 10 plus 3 30. Okay, you can create at 5, you can create at 7, anything. So this is how you can use the concept of higher order functions to actually take a function as parameter or to actually return a function, or to do both. Now, as a homework, I would like you to try writing this code. Okay, you have to tell whether to return cube, to return square, to return power 4, to return power 5 of a particular number. Okay, so I hope that this was helpful. See you in the next chapter. Thank you.